So what is a group? So a set, non-empty set G together with an operation star. So G star is a group if it satisfies following four properties. First, closure property, that is, for any two AB belonging to G, A star B should also be in G. That is, for any two elements A and B in G, if we apply the operation star, then A star B should also be in G. For example, if we take the addition over set of naturals, so sum of two natural numbers is again a natural number. So closure properties should be satisfied. Second is associativity. So you all know what is associativity. A star B star C should be equal to A star B star C. So this means you can operate any two Then third property is the existence of identity. So there exists some element E belonging to G such that if you operate any A along with E, you will always get A in return. So A star E should be equal to A should be equal to E star A for every A in G. And fourth property is existence of inverse. That is, if you pick any element A in G, there should exist some B in G such that A star B should be equal to the identity and which should be equal to B star A. So if these four properties are satisfied, first is closure property, second is associativity, third is existence of identity, and fourth is existence of inverse. So if these properties are satisfied by star on G, then we say that G star is a group. So let us take an example which you have already studied, which is the Z4, which consists of the elements 1, 2, 0, 1, 2 and 3. So this is a group with respect to addition. How? So how this is a group? So first we have to check closure property. So if you take any two elements, so suppose you take 0 and 1, so 0 plus 1 is 1, and if you take modulo 4, then you again get a 1. Then 0 modulo 4 2 is equal to 2, which is again 2 modulo 4 is 2. So now let us take example of 2 plus 3. So this is 5, and 5 modulo 4 is 1, which belongs to the set Z4, as we have already seen that for any A B. So A plus B, this is nothing but A plus B modulo 4 is nothing but the remainder obtained when A plus B is divided by 4, and we always know that the remainder is less than equal to 4. So this is equal to the remainder obtained when A plus B is divided by 4. So remainder, and we always know that remainder is less than equal to 4. So remainder always lies between 0 and 4. So this R belongs to Z4. So for any two elements A and B in Z4, your A plus B modulo 4 will belong to Z4. So Z4 satisfies closure property with respect to modulo 4. So first condition is satisfied. Now let us look at another condition, condition 2, which is associativity. And we have already done in our class that modulo addition modulo 4 is associative in nature. In fact, for any n, addition modulo n is associative in nature, so we don't need to prove this. Then third property is existence of identity. So in this case 0 is the identity, because if you take any element in Z4 and if you add 0 and take modulo, then you get that number as, you again get A in return. So 0 is the identity. Now fourth property is existence of inverse. This we have already done in the class, that for any A belonging to Z4, 4 minus A is the inverse of A in Z4 with respect to addition modulo 4. In fact, we have done in our class that, so 4 minus A, so for 0, 4 minus 0 is 4, which is equal to 0 in modulo 4. So 0 is the inverse of itself. 1, so for 1 is the inverse of 3, and vice versa. 4 minus 1 is 3, so 1 is the inverse of 3, and 3 is the inverse of 1. Then 2 is the inverse of itself. Okay, so every element, 0 has inverse, 1 has inverse, 2 has inverse, 3 has inverse, so each element has inverse. So fourth condition is also satisfied. So Z4, so Z4 plus 4 is a group.